Ladies and gentlemen present at eLearning 2014 conference. My name is Leandro Tibola and I go introduce the work named Virtual Laboratory for Promoting Engagement and Complex Learning. The authors are Liane Tarouco, Leandro Tibola, Gleizer Voss, Bárbara Avila and Fabiana Sgobbi. We form the Computer in Education and e-Learning Research Group. Before start, some information about us. We live in Brazil, the greatest country of the Latin America. Your state is Rio Grande do Sul, and we live at principal city, Porto Alegre. We study and work in graduate program of Computers in Education at Federal University of Rio Grande do Sul. The presentation follows these topics: introduction, creating learning tools for immersive environments, communication with the outside of virtual worlds, tutor for immersive environments, NPC behavior, and conclusions. The 21st century requires more advanced skills than before. Students, workers, and citizens must be able to solve multifaceted problems by thinking creatively and generating original ideas from multiple sources of information. The real world and the social relations are complex. Multiple interactions between people, technologies, purpose, and environments are part, sometimes move and act more in virtual space than in a real presence context. Social networks have become a key part of the global online experience and are becoming the most used service on the internet. So, the complex learning is necessary. Complex learning involves integrating knowledge, skills, and attitudes, and coordinating different abilities, which results in the ability to transform what is learned to real-world problem solving. The immersive environment potentially provides different possibilities, support for cooperative work and collaborative problem solving, and learning through action. Open Simulator is analyzed in this paper regarding the functionalities provided to build a rich interactive learning environment in order to engage students in learning tasks for the promotion of the complex learning. Dynamical interaction and learning solution contextualized may stimulate the student's ability to solve problems with a higher degree of complexity, as the incoming data derive from appropriate devices that capture information and signaling straight from the real world. To interact with world is need be there. This is possible through of an avatar. Avatar is the human's personification and way to interact with virtual world. Avatar design may influence user psychological connections to avatars and education-related outcomes of avatar use. Furthermore, the relationship between avatars and humans may imply that education-oriented virtual worlds should encourage a body-level connection to their avatars, perhaps through avatar personification. When avatars are employed as a motivational tool, they can be more effective motivators through adopting more powerful and evocative communication channels, verbal in text and visual in expressions. Avatar can be applied to the virtual interpersonal communication with haptic stimulation for real world. In this case, the virtual worlds communicate with a web service attached to a hardware component that stimulates haptic interaction. This approach can be used for lab experiments. The basic forms in virtual worlds are the primes, squares, spheres, triangles, for example, and the objects are built with primes. Any prime may have a scripting handling its behavior and reactions to behind touched. Any prime may have a script handling its behavior and reactions to being touched, be an avatar, or even to the bare presence of an avatar nearby. Scripts become primes and objects interactive and responsive. OpenSim uses the Liane scripting language. LSL is original scripting language of Second Life. OpenSim uses the OpenSim scripting language, or OSSL. To start program scripting, high-level authoring tool can be used. Scratch for OpenSim or Scriptastic are examples, but these tools has limitations regarding the complexity of the scriptings that may be created. However, they are simpler to use, and even students and teachers with basic computing skills were able to produce basic scripts to move primes and other reactions to touch. The addition of behaviors to 3D objects enable the students to have access to virtual simulation that allow contact with learning activities based on situations that mirror the real context in which school's knowledge should be employed. So, the complex learning that prepares students for a broader domain of curricular knowledge, where they develop skills that allow them to transfer this knowledge to various situations, requires developing technical skills to practice in the current context, as well as attitudes and approaches consistent with the experience. For example, a spirit of collaboration, autonomy, respect for others, and more. EcoMovie project is a sample of a virtual world created to promote knowledge through inherent relationships in ecosystems, offering students the ecosystems with specific disorders, where they must work to identify the reasons for alteration presented in virtual world. To develop virtual laboratories are necessary objects. The objects could be created by IT teams or end users. Usually, IT teams blend interdisciplinary areas with several professionals, and end user are alone or little groups. In both cases, when more complex objects are needed, people must have familiarity with programming language. As example of the effectiveness of digital labs, we can quote Dalgarno proposed a simulated environment to increase confidence and reduce students' anxiety through pre-laboratory activities before the physical laboratory activities. Chef suggests architecture to aid education and training in the control engineering formed by remote and virtual labs to enhance learning, autonomous tutoring, and collaboration awareness support. Pirker describes the implementation of a three-dimensional simulation framework to enhance students' understanding and conceptualization of physical phenomena in the Open Wonderland virtual world. After of the created objects, it must communicate with other objects or systems within or out of virtual world. The communication within virtual world can be by chat. A box allows user to type text to other avatars, NPC or objects, and by touch. That happens when avatars click on object that has a script that executes an action. The communication out of the virtual world uses these protocols: HTTP request, send and receive traditional commands of this protocol, HTTP executing a remote scripting or program, HTTP running a remote scripting or program hosted in a web server, XML/RPC enable bidirectional communication between virtual and physical world through remote procedure calls and XML data transfers. Despite to mimic a real lab and don't present risks from mistakes, student may become frustrated if he be alone, and a learning student may become frustrated if lack of proper support prevents the successful completion of the task. Thus, it is necessary to provide some substitute for a human monitor to guide, help, and give feedback to the students working in the virtual laboratory. A NPC, non-player character, is a solution. This works used NPC to guidance. Tatiana propose an adaptive model to control the behavior of NPC behind the states where they can be a set of possible factors that are classified as internal and external. Hanatunga investigates the connection between cognitive agent platforms such as belief, desire, intention, programming framework, and Second Life. Scott argues that avatars can be employed as a motivational tool, allowing nonverbal communication that is similar to human communication. Similarly to prims, NPC behavior is also governed by scripts. The incorporation of scenarios, objects, and avatars with scripts allows programs to customize reactions that user will receive in the virtual worlds when working through their own avatar. A NPC can track user interactive for guidance, support, and assessment purpose. The outer communication is employed to query and store data in remote databases or servers. The OSSL enable create NPC by OS NPC create command, which create a NPC by cloning the avatar or from a stored model into a node card. There are also OSSL commands to make a NPC follow the user avatar or anyone that comes close to it. The scripts should be placed in an item worn by the NPC. Despite this, to apply the NPC technology in the desired teaching-learning situation require more studies. By incorporating more intelligence and social behavior into the NPC, the virtual world is made more attractive because environment reactions become more intelligent, adaptive, personalized, and thus more effective and engaging. Soliman proposed the development of intelligent pedagogical agents, which are autonomous software entities with pedagogical purpose. Their main purpose is to provide a smart, pedagogically aware, and personalized learning environment interactions. A NPC must act as the same way as expected of a human, otherwise the realism of the experience will be reduced and engagement will diminish. In the game industry, artificial intelligence techniques have been used to direct the behavior of NPC for near of the human behavior. Some research about external chatterbots used in virtual worlds or AR showed chatterbots used to simplify the software development strategy for governing the behavior of virtual humans. Leonard and McClure presents chatterbots specialized in subject areas and have a knowledge base focused on the topics relevant to a particular educational activity being designed for the virtual world. Solomon shows the educational value of the intelligent agents for learning, while demonstrates new learning possibilities supported by them. To establish a connection between an NPC in OpenSea and a chatterbot, we used a chatterbot in a Pandora bot environment. In this environment, a chatterbot must be created and made public at Pandora bot to be usable as an extension of the NPC. In the OpenSea environment, the NPC was created and scripts were developed to set up the connection with Pandora bots as described in scripting code. In this scripting, bot ID is the identification of the chatterbot in Pandora bot and results from the process of creating the entity. The communication must be subsequently completed by linking the object with the Pandora bot's database. With the scripts of this slide, the NPC is created and fully connected to the Pandora bot's database and will send all messages received from the user to the chatterbot and then present the answers provided by the chatterbot. Customization of the chatterbot to a specific context is done by changing its knowledge base that is expressed using artificial intelligence markup language. As conclusions, we showed that virtual worlds may offer a unique opportunity for enhancing learning by enabling activity learning and the use of virtual laboratories that are especially relevant to promoting complex learning. Lastly, questions may be sent to Liane at penta.ufergs.br email. We will have great pleasure in answering it. Thank you to all present.